please welcome to the stage Michael Woodford.
Hi, everyone. I'm Mike Woodford, the chair of the Department of Economics here. Welcome to this year's Kenneth J. Aero Lecture. The Aero Lecture is an annual lecture sponsored by the three organizations' names have disappeared, but they were there a moment ago. It's sponsored by the Program for Economic Research in the Department of Economics here, the Center for Political Economy, which is part of the Columbia World Projects, and the Institute of Global Politics here at CEPA, that, among other things, has contributed the wonderful room for the occasion. And also sponsoring the event is Columbia University Press, that publishes the volumes based on these lectures, and you can see some examples of the past volumes on the table that was out there in the lobby as you came in. The series of lectures features distinguished economists whose work both builds on the scholarship of Kenneth Aero as well as his innovative spirit. This year's topic, as you can see from the title, is about the use of machine learning methods to model labor market transitions. The speaker that we have, I think, is the best person to tell us about this topic. Susan Athey is the Economics of Technology professor at Stanford Business School. She's a senior fellow also at the Stanford Institute of Economic Policy Research, a senior fellow at the Stanford Human-Centered AI Institute, and she's the founding director of the Golub Capital Social Impact Lab at Stanford, and I think she'll be telling us about some of the work of that lab today. She's been very much celebrated in her career, just mentioning some of the more notable of the many honors. She's a fellow of the American Academy of Arts and Sciences, a member of the National Academy of Sciences. She was a recipient of the John Bates Clark Medal, which, for those of you who are not card-carrying economists, is an award the American Economics Association gives every year to the economist under 40 who has made the greatest contribution to the field. And recently, she was the 2023 president of the American Economics Association. Her work is also very well known outside the academy and has had a lot of impact there as well. Among other things, she was the consulting chief economist for Microsoft between 2007 and 2016, and more recently, the chief economist at the U.S. Department of Justice Antitrust Division, which is why she's only giving this talk in 2025. We tried to get her a couple of years ago, and the DOJ got to her first, but we're happy to have finally gotten her to speak to you. As you might guess from some of those activities, Susan is an expert on the economics of the tech sector. But another important thing about her career in recent years is that she's been a leader in bringing methods of machine learning into economic analysis, and that's what we're going to hear about today. Let's all welcome Susan Athey.
Thank you so much for coming out this evening, and thanks so much for having me here. This is a terrific honor, and actually I just snapped a picture of the poster on the way in, and I was just thinking about what young me would have thought about being here. When I was in graduate school, Ken Aero was running around, and he taught me many things. He was, of course, did lots of different things and was good at them. He would also fall asleep during seminars and then wake up and have a really good question. And that taught me that it was okay to fall asleep in seminars. No, just kidding. I have a bit of ADHD, so I think that showed that you could think different ways and your brain might work differently, and that would be okay. Joe Stiglitz was advising one of my colleagues at Stanford, and there's so many, just like there's so many Ken stories, there's so many Joe stories. I think the one that stuck with me for today is that he would sometimes proofread Joe's papers, and the joke was that they would have sign errors in them, but there was always an even number of sign errors because he knew what the right answer had to be in the end. And so also being perfect with algebra didn't prevent you from doing, or being imperfect wouldn't prevent you from succeeding. So today I'm going to talk about a series of papers that are trying to study worker transitions. And some of the work is using machine learning, and some of the work is using digital technology to help people, and then evaluating it using both standard methods, like from randomized experiments, but also, although I won't have as much time to talk about it today, even those papers use machine learning as well to look at things like the benefits of personalization. So I'm going to start out with a project that is kind of motivation, if you like, for the whole line of work. And that's a paper about the impacts of layoffs and the heterogeneity in that impact. And so there have been many, many papers in labor economics that study what happens when workers lose their jobs. Layoffs are useful to study because when somebody leaves the job, of course, it's hard to know why, and those are different than the workers that stay. But at least when there's a layoff, it's about a group of workers, but not their individual characteristics. But despite the very large literature looking at those, most of the time when economists try to study, who's hurt and who's not, we do very simple types of cuts, like men and women, or college versus non-college, and so on. And there's a good reason that we do those simple cuts, because we're worried about bad data mining or p-hacking. We're worried if we keep fishing, we'll eventually find something and it won't be reproducible. And so one of the things that I'm going to use today are machine learning techniques that I've built that kind of get around that problem through a combination of sample splitting and kind of using an algorithm to find the groups that are most and least hurt. So in terms of the results, so what we do is well, let me describe a little more about the setup. So the setup is, I mentioned that on this slide. We matched 180,000 laid off workers across 22,000 plant closures in Sweden. And so we match those workers to other workers who are similar, both in terms of the worker histories and the establishments that they're a part of and the locations that they're in. So we do a rich matching exercise to find similar workers. And then we take the layoff is sort of the treatment, and we look at the treatment effect. So we use machine learning, in particular this causal forests method that I've developed, and we have if you haven't checked it out, we have a very popular R package that implements this. And you can think of how we make sure the results are valid is we use part of the data to put people into groups according to their treatment effect heterogeneity, and then we use another part of the data to evaluate the effects. So you don't have to worry about whether my model is right or not. I'm going to sort of show you what the model produces on kind of fresh data. Okay? So the outcome we train for is 1 year after earnings. So the model, when it's creating these groups, sees the outcomes 1 year after for some workers, but not the workers whose outcomes I'm showing you on the screen. And it doesn't at all see for any workers outcomes 2, 3, 4, 5, 6, 7, 8, 9, 10 years after the layoff. Okay? So in this picture, there's a lot of information. What we've done first is we use the machine learning model to put people into deciles, 10%, 20%, 30%, et cetera, in terms of the magnitude of the treatment effect of the layoff. And so what I've plotted here is the bottom decile, the people who are the most harmed, the top decile, the people who are the least harmed, and the decile containing the median. And what you see in the years below zero is the treatment effects of the people before they were laid off. And you see that we're estimating treatment effects of 0, and that's showing that we did a good job with our matching. After the layoffs, we see effects for the most harmed group. That's the biggest dip. It's about a 45% loss in earnings the year after they're laid off. And again, the model's only trained for that first year that's highlighted in red, but we see that that group is still about 13%, 12% less in earnings than the control group. The treatment effect is minus 0.12, 10 years after the layoff. So for that group, the layoff was a permanent event. And so what this says is that based on characteristics of people before they were laid off, we can very accurately predict on held out data people who are going to still be badly off much later. While there's another group that is still harmed, but the effects are much smaller in magnitude and they go away by about year 8. Then to try to kind of dive into this a little bit more, the top left panel is the same graph that I just showed you. Then on the top right, I'm showing for the top decile, I'm breaking out the treated and control group. And the difference between those lines is the treatment effect that's plotted on the top left. And so what that shows for the top decile of people is that the people who were resilient were kind of on an upward trajectory, and the layoff takes them a little bit off of that upward trajectory, but these people were doing well, and the layoff doesn't hurt them. If you jump down to panel D, the bottom decile of people, we see that the control group, the solid line, was on a bad trajectory without the layoff. So the people who weren't laid off, still over time, their earnings were going down, like they might have been laid off later or something else. So they were on a downward trajectory. They were vulnerable, but the people who were laid off did much worse. Okay? So this can, although this doesn't tell you exactly what policies work, it can help shine a light on policies that you might want to think about, and particularly what programs governments should consider to do this. And in the paper, we actually also incorporate the social safety net, which has been getting not as helpful over time, and so we see that the impacts are greater in more recent years. So then this gets into targeting. One of the things that you can do with machine learning methods is to think about how to target. And it can also be, hypothetical targeting exercises can also be used to kind of exposit what is the value of different types of data for prioritizing people or for identifying the people who are harmed. And so in these 4 panels, we try 4 different types of targeting exercises to try to see what variables, if you targeted on them, would identify the people who are most harmed. So the blue lines at the top are like random targeting. So if I took a random person from the data set, they're about minus 0.22, those are the blue lines, harmed. So the average person is harmed by about that much. If we take the red lines, say if we read off the points, and the red line is the same in all 4 panels, that's using GRF targeting. And so corresponding to point 1, that's saying what happens if we picked the 10% of people who were most harmed, then we get about 46% impact. And as you see, the red line is sloping up. As we include more and more people in our targeting group, the effect moves closer and closer to the average effect. Okay? So then we look at what happens if we target in the panel A based on schooling or based on age. And we see that targeting based on schooling or age is not as effective at identifying harmed people as targeting using the random forest. It's effective, but it doesn't capture all of the richness in who's harmed. Nonetheless, if you just targeted based on age, and it turns out to be like older people who are more harmed, that would already help you identify who's harmed. And of course, policies for people who are close to retirement might look very different than policies for people who are not. Then in panel B, we look at market variables, and we see that targeting based on manufacturing misses a lot. It's really like old people in manufacturing and combined with other things that are most harmed. Just there are people in manufacturing who are perfectly fine. So the green line is the manufacturing line. Population density of the market doesn't actually do anything. Then in panel C, we start looking at combinations. We look at manufacturing and schooling. And if you put manufacturing and your education level, that starts getting much closer to what the random forest identifies. So just those two variables, or manufacturing and age, does a little bit better than manufacturing and schooling. So it's really the older or low-educated manufacturing workers that the machine learning model finds. But so then once you know that, maybe you can throw the machine learning model out. But the machine learning model helps you understand that if I just look at those two interactions, I'm getting pretty close to what a more complicated policy would tell me. All right, so that's in Sweden, and that's manufacturing. I'm going to now show you two interventions and randomized experiments I ran to evaluate the interventions that are designed to try to help workers navigate transitions. There's a little disconnect here. This is, sadly, my work doesn't all completely follow a linear trajectory in that these applications will not be aimed at manufacturing workers because it's harder to help those people, frankly, and it's harder to, the interventions that I'm gonna show are digital interventions. The advantage of the digital interventions is that they are going to scale really nicely, and they're also easier to evaluate, but they're probably not helping Swedish manufacturing workers. All right, so let me give a little bit of a framework for how we're thinking about the problem of digital interventions to help people make transitions. So the starting point is that skills, I could give people skills, I could give them training, I could give them digital training, I could give them non-standard credentials, and that's gonna be cheaper than sending people to college. But that's only gonna be helpful if that can be credibly communicated to the employer, and of course, it also depends on what does the employer believe about that credential. So we're from the agenda perspective, we can think about improving approaches that help you demonstrate your skill. That's going to be one part of this pipeline. If you can't demonstrate your skill, there's no point in having it. And then we can also think about, okay, if we can show that it works, if you have a digital skill or a non-standard credential, if we can show that a non-standard credential does move the needle with employers, then we can invest in building those skills and getting more people to get the credentials. But one of the reasons I started thinking about breaking this down is during the pandemic, some countries and governments were asking, like, what can we do? Maybe we should try to spend a lot of money getting people education during this time. And the problem is I could say, okay, let's spend a couple $1 million and try to convince a bunch of people to take courses, but that's expensive. Especially if I'm trying to do like some kind of randomized experiment, I've got to sort of convince people that wouldn't have otherwise taken the courses to take them, that it's costly, it takes their time. And I'm not even sure whether once they get a credential, that credential will help them. So I wanted to really think hard about the process through which employers receive that information before going out to investigate, the harder problem of getting people skills. I want to mention a couple of things that I don't solve in either of these two papers, but that are very important, and they're really like fundamental problems to this type of work. And that's partial versus general equilibrium. So I'm going to show you one program that was very small. So if I want to think about evaluating that program, it didn't have any general equilibrium effects. But if I tried to scale it to a whole country, then did I do that? Then it might have general equilibrium effects. And so again, credentials are valuable if employers learn their meaning. So when you first launch your credential, it might look like it has no effect because there's a chicken and egg problem. I've never heard of the credential. I don't really care about evaluating somebody with it. That's why a degree from someplace like Columbia has value, because people already have decided it has meaning and they don't have to go and look it up. It's less valuable if it's more common. So if I give 100 people in a country versus 10,000 people the same credential, there's like downward sloping demand for that credential. So that's a negative effect on the demand for the credential. And then actually in the future, everything about this is going to change because AI might, change the way people signal and change the way employers evaluate. And so everything about the way a credential is received could change as it shifts from humans to AIs doing the evaluation. Definitely not solving that today. Okay, so with that framing, the first paper we're going to look at is a digital program that helps women build portfolios demonstrating skills relevant to IT jobs. And so manufacturing declining in a lot of developed countries, IT growing, we want to help people do this. And so that's going to be hitting the part of this chain where they both are building skill and demonstrating the skill. So we're going to help them build a portfolio that demonstrates their work. It's kind of like a job market paper for those PhD students and faculty here. That's a project that shows that you have the skills. So this is a project that we worked with a very small organization in Poland. It's kind of a for-profit small organization that works on women in IT, and then they had this small not-for-profit mentoring program that they were running when we met them. And it was like 2 people or 3 people running this mentoring program. And it's sort of similar to some of the things the American Economics Association does and other things where it's trying to match up a mentor with a mentee and then try to help them gain skills and network as well. So we then said, well, that's great, but what's the problem? They said, well, the problem is there's not that many mentors. Like, we're trying to get women into the IT industry in Poland, which is growing, but there's not a lot of women there, and so they're going to have a hard time. It's a hard time to scale the programs. They were doing about like 200 or 300 women at a time, like every 6 to 8 months. So this program, the mentoring program, is what they were doing, and so we proposed to them to create a new program. So we actually developed the program entirely because they don't really have any people to do it, so we developed it in collaboration with them. And they managed, but they used their existing web presence and kind of Facebook page and so on, and LinkedIn to kind of recruit people into the program, and then they managed the administration of the program. And I'll show you in a minute, this was successful, and they're still running the program. When the war with Ukraine and Russia broke out, they actually had one that brought in Ukrainian women, so who had come to Poland. So this was a very meaningful experience for me as well. The Challenges program, what you do is you have a program where the women are told every 2 weeks they need to submit an assignment. And then at the end of it, it adds up to a portfolio item. So I've got an illustration here for if you're applying to be a user experience designer, you would create a little design for an app, and that's what you would show as your portfolio. So of course, people could have done this on their own. They may not need a program. If we think about what are all the problems this is solving, well, we went out and interviewed the employers and asked the employers what they wanted and what would help them. And then this organization had some credibility. So we're convincing the women that it's worthwhile for them to complete the portfolio because this is going to be valued by the employers. And so it's really tailored to what employers want. So we kind of solved the chicken and egg problem by hand. It's a very cheap program, though. It costs about $15 a person. And that's just like administrative overhead, basically, like having somebody answer emails. In order to evaluate these 2 programs, we ran 2 parallel randomized controlled trials, randomized experiments. The Challenges one was easier to describe. To have some truth in advertising, we accepted the first 100 applicants, and then after that, we said the program was reaching capacity, and we started randomizing them into treated and control. For the mentoring program, we had to deal with the fact that in the existing program, the mentors chose the mentees, and they felt that that was very important. They liked choosing their mentee, and these are volunteer mentors, so you don't want to take that away from them. So the way we finagled that is we asked the mentors to each choose 2 mentees, and then we randomized between them which one actually got mentored. And that way we controlled for selection. It also gives us this really nice opportunity to understand the role of selection, because we can see what's the difference between the people the mentors chose but who didn't get mentored and the regular population. And so all of that can be summarized on this graph with the 4 colored lines. We're showing over time since the program, the challenges control, the challenges treated, the mentoring control, and the mentoring treated. And you see the mentoring control group is way above even the challenges treatment group. And that's saying the mentors are really good at picking people who are likely to get a job anyway. And that, of course, but they still have a treatment effect. The light green boosts that even further. And I guess, again, if there are graduate students here, you might recognize some of that in your life, like the star students get the best advisors, but probably the best advisor still makes them better. But it's possible that social welfare would go up depending on how you weight the objective function if the best advisor actually mentored some more people in the middle too, because they might have even greater value added for those people. And so that's what I'm not going to be able to show you all of that, but we actually show that the people the mentors pick are not the ones with the highest treatment effects. But overall, the magnitude of the treatment effects is similar between the two in terms of getting a job, and although proportionally the effect is much larger for challenges because they're starting at a lower baseline. We then also look at some subgroups here, and we find, for example, that the challenges program has a bigger treatment effect for people with low experience. The mentoring works very well for people from small towns. And we interpret that as saying, well, people from small towns may be really well suited for a job in tech, but they just need somebody to help them introduce them to some people. So the mentoring might be really good for that, while the challenges program might be better for people who need to actually develop skills or who are less obviously suited and they need more than just an introduction. Okay, so that was the first project. The second project is about Coursera. And in this project, we're trying to understand whether getting a credential is going to help you get a job. And I'm going to say this again, but I just want to say it at the beginning. We are not studying the effect of having the credential. We are going to study the effect of the employers being aware of the credential. Okay? So we're just going to isolate the effect of making the employers be able to see it and verify it more easily. And that goes back to my earlier point. Once you've established that, then it's much more expensive to study the effect of having the credential, because then I have to get people to spend a lot of time. So EdTech is growing. Online platforms are growing. So I already covered that. So here we're going to look at these two research questions about showing the value of credentials. What we do in this case, we also build a new digital product together with Coursera engineers. And this new digital product is a product that makes it basically 2 clicks to have your credentials shown on your LinkedIn page. Okay, so it's an engineering feature inside of Coursera that connects to LinkedIn's API to get a verified credential. And then when you if an employer clicks on the credential, they'll come back to Coursera and see that it's a Coursera verified credential. Okay, so that's how the credentialing works. And then we also have some nudges to try to get people to do those 2 clicks. So that's the overall policy. The policy is a 2-step process for showing your credentials and nudges that help you get there. So from a policy perspective, from Coursera's perspective, they just want to understand, is this a good thing, and should I release it to everybody? And based on the results of our work, they did release it to everybody. So that was good. So now, millions of people experiencing the feature. From an economics perspective, or more kind of structural perspective, we don't just want to know, did this particular implementation at this time with the nudges and the process work? We might also be interested in because, for example, people might not have complied with that nudge, and we see who they are. So we might instead be interested in the local average treatment effect, or the effect of the treatment on the people who were actually induced to post their credentials as a result of the treatment. And that's going to have more of a deeper economic interpretation. So we study both of these things, and I just want to highlight that it's not like one is right and one is wrong. They're answering different questions. The intent to treat is, what's the overall effect on everybody who is exposed? The local average treatment effect is, what's the effect on the people who were induced? So And so as we go through this process, then what happens is the Coursera learner completes a course, they receive their certificate, and only then do we do the randomization. So everybody in our sample has had the same experience up until after they receive their certificate. Okay? So the treatment group and control group both have certificates. Then we randomize them into the 2-click process where they get these nudges. We've got little examples of the boxes there. And then they choose to add it to their LinkedIn profile. Then we just watch their LinkedIn profile over time to see whether they get a new job. And so that solves a bunch of problems because we're able to then to follow them for a long period of time, and we don't have to worry about non-response and asking them. The other way to do this would be to do it in a country and match it to data from governments. Very hard to do. Survey non-response just makes this super hard to do with just surveys. Most of the courses are audited for free. This is usually $29 to $99 courses, about $39 to $79 a month for a series on specializations and professional certificates. The sample that we use is restricted to those who are in developing countries or don't have bachelor's degrees. And that's partly we want to see the impact on people who are sort of more disadvantaged. Now we have 765,000 learners in the full sample, but only 37,000 of them have we matched to LinkedIn. And that's because we're using the LinkedIn links that they put in before randomization. And so we didn't intervene at the stage of getting them to share their LinkedIn profile. So that's a small subset, and in the paper we do a lot to kind of study who those people are. In the interest of time, let me just show you what kind of the results look like. We have the treatment and control group, and then the green is the control, the red is the treatment. I've got the dotted line showing because after the 7th month, we don't observe all of the cohorts anymore, so the sample is kind of changing as we go further out. But we see that there are treatment effects on getting a job. We then kind of break this out into a couple of categories. We look at what are the effects on getting a new job overall. That's kind of what I just showed you. And it's about 6 percentage points over the baseline. If we look at just people who get new jobs in the scope of what their credentials were, it's a lower baseline, actually a higher magnitude and a higher percentage. And then if we go to people who are getting a new job in the scope of their credential who didn't have an old job in scope, the sample shrinks even farther, and we get an even bigger percentage of baseline increase in treatment effects. So this is basic evidence that making it easy for people to show the credential to their employer is helpful. Then we look at the local average treatment effect, and essentially now we're adjusting for the fact that that a lot of people didn't comply. So in the first stage, only 3% are actually there's only a 3 percentage point increase on sharing the credential as a result of the treatment. So that then leads to a much larger second stage. The local average treatment effect is much larger because we're dividing by the low first stage. Actually, I think these results are they're big standard errors. They're actually a little bit implausibly large. And so, there's some questions we're thinking about with that. For example, could it be that you actually bring it up in the interview because you were reminded about it? So there could be some violations of the exclusion restriction. And that might be a reason to focus on the intent to treat as well. We looked to see we did look at that to see if the feature got you more engaged in LinkedIn, and we didn't find any difference in the profile length or the activity on LinkedIn as a result of the treatment. We finally break this out. We use machine learning to divide people based on their pre-treatment characteristics into low employability, medium employability, and high employability. And we show that the absolute magnitude, as well as the percentage magnitude of the treatment effects are concentrated on the people who look like they had low employability at the beginning. And so that's hopefully showing that this is helpful. Okay, So now I'm actually going to switch gears a little bit. So first I said there's a problem, then I looked at 2 policy solutions. The last project I'm going to talk about doesn't fit quite as well. It's also about worker transitions, but it's about AI and it's about transformer models. And so, everybody wants to talk about that now. So here I am. I actually started working on transformer models before ChatGPT came out, so I'm one of the cool kids. And I've got a series of papers. What I'm going to talk about today is a project about decomposing changes in gender wage gaps. I also want to mention that we've been, and that was based on custom transformer models, I'll show you. We've also got a couple of papers and more on the way where we're bringing in the large language models directly to economic modeling. Okay, so in labor economics, we want to understand transitions. I just showed you a bunch of reasons you might want to study transitions. We want good methods to predict the counterfactual. We want to know, what would you have done if you hadn't been subject to this intervention? There's another category of problems that I'll talk about today, which are called decompositions. And it's basically trying to say how much of, say, the gap between men and women's wages is accounted for by the fact the gap in today's wages is accounted for by the fact that you had different histories leading up till now, and how much is unexplained. And that can understanding the answer to that can help you with policies, because if everybody gets the same wages today, but just women had different histories, then you should intervene earlier in the career. Whereas if 2 people who have identical career histories have very different wages today, maybe you need to think about bargaining and other types of considerations. Okay, so we want to think about how to estimate and predict career transitions on small data sets. And that's challenging because actually if you think about saying what's the next job a person's going to have, if you have 10 years of career history, there's a lot of possible career histories you could have had. And so that's a very challenging problem, and in this project, we're going to bring in modern AI methods to try to address that problem. So in particular, we're going to use the paradigm of foundation models and fine-tuning. So what is a foundation model? Well, everybody's used ChatGPT, so I'm not going to explain that to you. I'm going to talk a little bit about what makes it work. I say there's 3 big ideas. The first big idea of training one of these foundation models is that we need lots and lots of data, and they tend to be self-supervised. So if you have a paragraph, you're looking at that paragraph, and you're taking the first word and predicting the next word, first 2 words and predicting the third word, first 3 words and predicting the 4th word. That's the architecture behind ChatGPT and the architecture behind transformer models. But the key is I don't have to label what the words are. I just need a paragraph, and every word is the right answer to the problem of what comes next for the sentence before. So even one paragraph has a whole bunch of prediction problems, and if you have a whole bunch of paragraphs, then you have a lot of data. The second big idea is to use embedding functions, and that's basically to transform high-dimensional data into low-dimensional vectors. Those vectors don't have any direct meaning, but you can think about them as covariates that you might use in a regression. And so if you think about the space of all sentences in the world, there are many, many, many of them, but I'm going to reduce that to be captured in a 4,000 dimensional vector. And the key thing about these low-dimensional embeddings is that if you have 2 4,000 dimensional vectors that are close in Euclidean space, they're going to be close in meaning. And in particular, they'll be close in meaning to the extent that they predict the same next word. Okay? That's the second key idea. The third idea, and you don't hear about this as much, but it's very, very common in industry right now and in parts of academia, is fine-tuning. And so that is, we start with, say, the model that Facebook put out, Llama, or another open source model, and then we take it to a smaller data set, and we continue the training just as if we were Meta training the big model, but we train it on our small data. So it's trying to predict the next word in a specific corpus of data, and then it gets much better at that. Okay? So those are the 3 big ideas of the foundation models, and we're going to make use of those in career trajectory predictions. So in particular, if we suppose our end goal was now to predict wages, so we want to take the history of jobs and use that to predict wages. Well, if we wanted to be fully non-parametric, we could delineate all the possible histories, which is a very large number, and have an indicator for whether you had that particular history. But there's too many histories, like, more than probably atoms in the universe. So too many histories, so we need to reduce the dimensionality. So then how do we do that? Well, it's going to be hard to reduce the dimensionality in a government survey data set. Say I have the PSID or the NLS at Y, I have tens of thousands of people, maybe 100,000 transitions. That's not enough to learn a great representation of what jobs mean and what sequences of jobs are common. So what we want to do is bring in some other foundational information. So in particular, what we do in this project is we get a data set of 23 million resumes, so that's a lot of resumes, and then we build a custom transformer model to try to predict the next job in a sequence. So just like, and this is just like what the text models do, they predict the next word, but jobs are words. So the architecture works just as well. There might be 30,000 words or 50,000 tokens that you use, and there's 330 jobs, so it's a smaller problem. That's why I could do it on on Stanford machines and not using $100 million to do it. But it's the same exact model, except we're gonna improve on it in a couple ways for this application. So what we start with is just the next job prediction problem, no wages, because I don't have any wages in my 23 million resumes. I just have next jobs. So you think, how is that going to help me with wages? Well, it doesn't help me with wages directly, but it helps me indirectly, because it helps me understand the meanings of jobs, and it helps me understand the meanings of job sequences. And if I can understand job sequences well enough to predict your next job, then I probably also understand something that's relevant for wages. So that's the idea. So we basically train a representation to predict the transitions. And this lambda theta of H, that's a function that maps from the job history into, in our case, it's I think 980 dimensional vector. And that's the representation we use. So putting these pieces together, the pre-training or the foundation model training is done with resumes. The input is just sequences of jobs. And our goal is to predict the next job. And then we learn a representation. Then we move to survey data set where we do have wages. It's smaller. And we just keep training, but now we don't train to predict the next job. We train to predict wage. Okay? So that's our model. We do a few other things. We allow covariates, and we also give special treatment to staying in the same job, because you don't say bird, 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 but you do stay, waiter, 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 waiter. So we modify the architecture a little bit. So just formally fine-tuning, there's these parameters theta of the embedding function, lambda theta, it's a neural network. We take gradients of the objective function, and we train the parameters theta in the resumes. Then we stop, and we load up the survey data, and then we keep training those same parameters theta, but with a different objective function and different gradients and different data. And we minimize mean squared error. And at the end of that, we have parameters theta with parameterize this function lambda theta that maps from histories to a 1,000-dimensional vector. And then we can treat those as if they're data and use them as we like. So if we compare that to what we typically did in economics, and I like this problem of the gender wage gap, because there's actually like tens of thousands of papers that have studied this, and there's like hundreds of thousands of papers on wage regressions. So it's got to give a fair fight to machine learning, because if you think about all the research assistants and all the regressions they've run, it's a lot of wage regressions that have been run. But the restriction is often just that, there's so many combinations of covariates, and you run out of data. So these embeddings kind of reduce the dimensionality and start with some structure so that we can incorporate richer history. So we compare our model to a model with just 21 categories, coarse-grained occupations. That's something that's commonly used. You can also use 330 occupations. It already starts pushing the limits of the data. And then we also try lasso, although that's not commonly done. And we include constructed summary statistics of the data, like region, union status instead. Our alternative is that we include a shallow neural network, a simple function of our 1,000-dimensional embedding in the model. And then we look at held out R squared in a test set. So if we look at the standard labor economics models, the R squared's about 0.42. Jumping to the bold, our model gets you to about 0.52. So despite all those research assistants and all those years of regression running, we got a 25% improvement in the R squared. And the improvement is not only due to functional form of the current occupation or capturing workforce participation spells, it's really using the full history. So then we go to gender wage decompositions. And when you do a gender wage decomposition, actually you care not just about predicting wage, but actually about predicting differences in wages between men and women. Estimating, it's not the same as estimating treatment effects conceptually, but statistically it's the same as estimating treatment effects conditioning on covariates. And so what decompositions do is they say, I'm going to take the part of the gender wage gap that is explained by the fact that men and women have different histories at a point in time, take that one part, then there's another part which says if they had the same histories, what's the difference in the wages? So we prove a new theorem, which I'm running out of time, so I'm not going to be able to talk to you very much about, but let me just say verbally what the contribution of the theorem is. We have a whole theory about how to estimate treatment effects under unconfoundedness and how to do decompositions when there's a small number of x's. We show that you can apply the same theorems as if these estimated embeddings are actual data, and the same theorems applied, only conditioning on the embedding, as long as we get rid of omitted variable files fast enough. And then we come up with methods that target omitted variable bias. And the basic idea is the only thing that's going to screw up a gender wage gap are variables that are correlated with wage and correlated with gender. And so in our optimization routine, we optimize for finding those variables. And it turns out the magic method is the same as for my heterogeneous treatment effect work that we use in our GRF package. So we find that when we start optimizing for not having omitted variable bias, it could make prediction worse, it could make it better. It turns out it makes it just a tiny bit better in our case, which is kind of interesting in and of itself, because it's saying that, actually you're not harmed by trying to do this extra thing. By thinking about both gender and wage at the same time, it actually helps you a little bit. And then this last slide, I just want to give you some interpretation of what we find. It's actually very hard to interpret these models, and so we came up with kind of a heuristic approach. We built kind of a regression tree that tried to predict what are the most important categories or groupings of these embeddings in terms of predicting wages, conditional on the current job. So manager is a really big current job, and then we find the ones that have the biggest improvement in R squared. And so here, what I'm showing you are the subdivisions, the top 5 subdivisions of manager based on our embeddings that predict wages the most. We've got software developer, and then the words are the jobs in the history, not the current job, but the jobs in the history. So if you're a manager today, but you were an electrical engineer yesterday, that's very predictive of your wage. It's also very predictive of your gender. And so it's 11% female in our sample. This is a big contributor to the unadjusted gender wage gap. Similarly, if your past job included cashier and homemaker, that's a job and now you're a manager, you're 93% female, and the wages are low. Okay, so now you start to see how adjusting for more and more of history can start untangling and disambiguating what some of these jobs are. But there's other jobs too. Even sales jobs have a wide range, and you get clues about what kind of a sales job it is from their previous history. And if nobody had ever run one of these regressions before, you could just say, no duh, Susan, your machine learning program figured out the obvious. But there's hundreds of thousands of regressions have been run, and people ran out of data, and they didn't include all these things. And so that's partly what's going on. Okay, so that's the last slide, and this slide is actually showing we try a couple of different ways to to do this, and actually all of the different methods, this is kind of just technical, to do the debiasing of these models. And we find that all of them explain about 17% of the remaining wage gap when history is not included. So it's not a huge change, but it's a change. So overall, I think this shows that these transformer models have a lot of promise, and they allow us to study dynamics in ways that we maybe thought was hopeless. This is just the beginning of how to do this, but I expect that we're going to see a lot more action in economics, because it's not like people didn't want to do this, it's just that we thought we couldn't do it with the data that we had. It turns out that using foundation models gives you a big boost up to then study problems in smaller data sets. Thank you.
Okay, to offer some brief comments on Susan's talk, we're going to have three distinguished discussants who should come up to the stage. So we'll have three discussants. First, we'll have Bentley McLeod, the Samim Nemne Professor Emeritus of Economics in our Department of Economics here at Columbia. Suresh Naidu, Jack Wang, and Echo Ren Professor of Economics, who is also a Professor of International and Public Affairs. And then finally, Joe Stiglitz, Nobel Laureate in Economics, university professor with appointments in the Department of Economics, the Business School, and the School of International and Public Affairs. And Bentley will be our first discussant.
How do I do the slides? Oh, I see. All right. Well, thank you very much. Thank you for inviting me to comment on this for this incredibly distinguished panel. I mean, the first thing is I enjoy commenting on the brilliant work of Susan Athey. Her productivity sort of reminds me of our dear colleague Joe Stiglitz. So they're sort of in the same league of being incredibly productive. Each paper in this talk actually deserves a long discussion, which I don't have time to. So instead, I think Mike Woodford sort of asked me to talk about AI and machine learning or the digital economy more generally for labor markets. And so what I'm going to do is I'm going to talk about the good, the bad, and the ugly. Okay? And in brief, the good is actually going to be Susan's work, and then the bad and the ugly are going to talk about aspects of machine learning and AI that are relevant for labor economics. And in some sense, the reason I'm discussing this is also to serve prime students out there on topics to be addressed. And these are going to be questions that are serious questions, but not currently being well addressed with the current technologies. In particular, what we'll see is that Susan's work is going to provide some very useful tools to understand current labor market issues, but there are going to be some issues raised by these new technologies that I want to talk about as well, that I think worthwhile thinking about. The good, the immediate benefits of AI. So first thing to keep in mind is that AI has, all of us are using ChatGPT. It's arrived very quickly. So the red dot here is a paper by a recent paper on the dangers of AI. And it's only one dot because it's so new, but you can see the red dot's above the green line and the yellow line at the beginning. The green line is basically the rise of internet usage in the economy. The orange line is sort of the use of computers, and the AI is sort of higher. And so what we can expect here, if the future is any guide, is that red line is going to continue at a higher rate of adoption than internet or computer use. And that, for a lot of people, that's concerning, and there's been a lot of concern about this. But before I talk about the concerns, let me talk about use this to put Susan's work in context. So we had 5 papers. Each one of them deserved a long discussion, so I don't have time to do that. So the Athey, Simon, Sands, Vikram, Yokamovich paper, use a machine learning algorithm to detail the cost of job loss. So what I'm going to do here is I'm going to break up into sort of two parts. One part is how these techniques are very useful to describe what we see in the labor market, and the second part is what we can do are policies actually improve matters. And so in this machine learning algorithm, what they're able to do is basically look at the cost of job loss based by worker characteristics, and the benefit of studies to assist in the design of more efficient targeting of harmed workers. In this particular case, they found that older workers in routine tasks were particularly harmed by job loss. The next two papers are Athey, Brunberg, Du, Kanaura, and Vafa introduce the career model to assess the role of job histories on labor market outcomes. The allocation of process for workers is very complex and poorly understood. And I think one thing to keep in mind, even as labor economists, we're just basically scratched the surface of this complicated system. The labor market is millions of individuals that are getting matched every period. It's a very complex process. And I think what's exciting about this work is to take these very complex process and be able to say something sensible about how worker job matching has occurred. And then what they use this model for an actual practical application of getting better estimates of the gender wage gap. So I think this is really exciting work, and I think could potentially help us understand complex phenomena. And then the final two papers are basically experimental evidence on how online services, or I would say the digital economy, can help and improve labor market models. So these are very practical solutions that can help people today. I got 5 minutes left. I've got this red thing. Have I used that much time? Okay, the bad. So I want two things about the bad. The first bad is one thing that we don't do very well is the modeling of expectations. So there's a really neat paper by Kovundis, Chai, Lang, and Malhotra that basically looks at the effect of expectations on labor supply. In this particular graph, we look at the fraction of workers by age that are truck drivers. And what you can see in 2006, between ages 35 and 45, there are, more than 4.5% of workers were truck drivers. Very important job. As you can see, in 2020, it's dropped dramatically. Truck drivers are saying, look, why would I want to become a truck driver when we're soon going to have this self-driving trucks? The interesting point is their behavior is being pushed by expectations, but we still don't have self-driving trucks today. So in a sense, there's an issue of how do we, in some sense, match what's actually going to happen with their expectations. But what we can see empirically is just the threat of AI is causing people to adjust their behaviors in the labor market in ways that are actually difficult to anticipate. So that's what they show here. So more generally, all jobs require some relationship-specific investments, and hence job choice depends on future expectations. So in the examples that Susan was pointing out, these are very short-run types of jobs. But when you're thinking of your career, should I become an economist or go into computer science or some other area, I'm looking at doing an investment today that's kind of a 30 or 40-year horizon. So a big open question is how are these new technologies going to affect these long-run returns? Current AI models, even though they're really cool, they're retrospective. They're taking existing data sets, your text that you write, they do non-structural inference of existing data, hence by construction, they're not forward-looking. So the good news on that is all of you as economists have a job to do. How do we construct models on how do we predict what's going to be the future outcomes? This problem is well recognized, and many people in the AI area I've talked about this and worried about what the impact of AI is going to be for the future. And there's this study by Bengio in 2025 that I got some of these graphs from. Let me go to what I think is sort of the final point, the ugly, the impact of AI and the meaning of work. And I think this is a very serious problem. The paradigm labor market model builds on the classic algebra model that assumes that work is only valuable for the income it produces. It's a useful model, a good way to start, but given that we spend much of our life at work, we clearly value the time at work. All of us here who are academics, we enjoy our jobs, we like being on those jobs. The issue then is and I remember listening to somebody say, oh yeah, we're soon going to have Einstein in your pocket. So there's a program called Yoke AI. It's your secret study weapon to ace any topic, any school exam, any standardized test. It's like having Einstein and AI in your pocket. Well, you can easily, the next step is, look, if I got Einstein in my pocket, why do I even need to take these tests? Einstein in my pocket can actually take these jobs, right? And so then what you have a situation is that being Einstein or being Joe Stiglitz is a great job, right? Are we going to have no more future Joe Stiglitz? I mean, that's the question we should be asking ourselves. And I think one of the ways we can see this empirically, if you look at this graph, this is basically different areas of study, and we're looking at how quickly this is catching up to the human level of performance. So the red line is reading handwriting. We're basically in 2016, we can read handwriting. The orange line is image classification. Then we have a couple image classification. We have basic level reading is the green line. The blue line is basic English language understanding. The other, I guess it's teal. The other blue line is multitask language understanding. Then we have general problem solving is sort of the purple line, and then we have PhD level science questions. So what this is sort of illustrating is that these AI tools are going to take our jobs. And it's something we should actually worry about. And in fact, you think, well, maybe that's a little bit, do I have any evidence to worry about this? Well, we do have some. AI is certainly increasing our productivity. When I did these slides, I now use LaTeX is much easier for me to use since I'm a little bit ADD. I make lots of coding errors, but now with AI, I can code more quickly. But we have to remember, how do we evaluate changes when AI replaces the activities that humans find very rewarding? The question is related to growing literature on dignity at work. Hodgson has a nice book describing the various ways by which we get value from the jobs that we have. Dubé, Nadeau, and Reich, Nadeau here, provides a good start on how we begin to measure the importance of work as a consumption good. More ominous is the recent evidence, we actually have evidence showing that AI tools increase research productivity at a material science group at the cost of lower job satisfaction. There's a paper by Toner Rogers at MIT. It's a fantastic paper, and what he shows is that while AI made workers more productive, they're less happy, right? And that's, I think, in some sense, what we have is Susan Athey has started an important agenda on the use of AI and machine learning tools to understand and improve labor markets. It's an exciting agenda with many open questions. How will labor markets adopt and evolve over time? How should we evaluate the impact that these changes will have on worker well-being? And how will AI impact the welfare of our most skilled workers? And I'll stop there. Time is out.
All right, thanks a lot, Bentley and Susan, there's so much you could talk about on both of these talks, and so I'll keep it maybe quick. So when I was thinking about what this is doing, the analogy in my mind is that it's like what happened, like why was finance such an early field that sort of took off with data and machine learning and just ran with it. So data was abundant. It's also an incredibly rapid area, so you get like new data points every 30 seconds. And so, it was able to really take advantage of like reams of data and was sort of always like the cutting edge of what you could do with data and prediction. And now we're sort of starting to build that to the labor market. And what's interesting is also thinking about how like financial economics, there's a great book I like called An Engine, Not a Camera, which is that financial economics didn't just like study financial markets as they were, but was actually actively assisting in creating it. Like Black-Scholes and these equations don't just like price assets that already exist, they enable assets to come into existence. And so this idea that like labor economics might, and I think these tools are sort of pointing in the direction, don't just look like studying the world as it is, they're actually going to wind up constructing new forms of labor markets and new forms of labor contracts. So I have sort of three groups of comments, and we should have made slides. So one is the thing that Susan didn't talk about, but I just kind of love this paper, is this labor LLM paper, which is basically like they have this customized model of career that sort of predicts these occupational transitions using this bespoke, hard to get data set of resumes. But then it turns out you can just ask ChatGPT, give it a sequence of occupations, and ask it to predict the next one, and it does pretty good. And so that suggests there's already a pretty decent model of occupational transitions stored somewhere in all of the stuff that GPT has learned. And so that you're already able to like extract a pretty good model of labor market transitions without having to fine tune on resumes. You need to fine tune a little bit, but there's a lot already there. And I was sort of thinking, why is that the case? And it's partly because in all of the material we've put on the internet, we've talked a lot about jobs and like what occupations are, and they are just cultural objects that we've used to describe different experiences of work and their relationships to people and each other. And so they're like an occupation is like a cultural construct that we've imposed on the world, and you can sort of see, and we might not agree on what this means. So those of you that have looked at this know about ONET, which is a data source that everyone uses to study occupations. It's now used to predict all kinds of things about the future of work. So a project I have with two students that I think are in the audience is basically studying how, like, ONET actually sometimes it asks a worker and sometimes it asks an expert to assess an occupation. And those two views often diverge. And so, like, an expert's view of what is an important skill for a job is actually often very different from what a worker thinks the important skills for a job is. So what we all think is like, oh, that's a routine job. There's actually, when you ask a worker, it's not a routine job. Or, you know, and those all kinds of things are. So I think this idea that, like, what we're learning about the labor market, both in the LLMs, what's the skill credential, these things, they're not just kind of objectively given. They're things that we have to make meaning about. And you know, the concepts we're using have to be constructed and validated, and we might disagree about what they mean. Okay, the second and maybe last point I want to sort of talk about is the extent of the heterogeneity in the labor market. So I was actually sort of, you know, when career gets you to like 0.51 out of sample R squared, I just want to start with like Jacob Mintzer in 1958, gets an R squared of like 0.25 with just education and age squared. And so it's just like those three variables get you a ton of the variation in the labor market, and it took career to get us to 0.5, and so there's just like still a ton of unexplained variation in the labor market, and so it means there's still lots of work to do, and it also means that there's just basically some still clear things that we're not able to model very well. And one of the questions is then like, well, what happens when we do make that heterogeneity observable? So, you know, I work a lot on monopsony, and monopsony is basically all about the fact that there's like unobserved heterogeneity and outside options, and employers don't know who's got what outside options, so they lowball the wage, accept some people quitting, but are able to mark down the people that stay. And so when you think about, okay, well, what will happen when we make all of that unobserved heterogeneity and outside options legible, you know, I'm willing to bet, you know, employers are going to get it and HR analytics companies are going to get it before, say, the UI agencies get it. And so they're going to basically be selling and making predictions about what workers' reservation wages are. And so we're just going to see a giant, you know, increase in the various techniques of like basically complete price discrimination, which is efficiency improving, so there'll be less unemployment, but it's going to transfer all the surplus to employers or whichever platform is kind of delivering this good. And when you think of the basic economics of like two-sided platforms like LinkedIn, the logic is right, like soak the inelastic side and like transfer it to the elastic side. And if you think that generally workers are much less elastic than employers, then kind of the logic of the kinds of algorithms and tools that are going to get developed on platforms like LinkedIn are basically going to be like, how do we kind of like extract a little bit more from the inelastic side and like subsidize a little bit more the elastic side. And so I'm kind of curious to think about why we think that, you know, for all of these great labor market tools, I'm like very skeptical that the economic forces and political forces at play are going to make it that that government authorities and policymakers are the first ones to use these tools. I think we're first going to get like HR analytics companies using them to like kind of predict reservation wages, and then we're going to see changes in employment happening first on the private sector before policymakers get engaged. So in my last minute, then, I sort of want to talk about the sort of other uses of AI in the labor market. So a lot of what I do is kind of run RCTs with unions, and one of the things that is interesting is trying to leverage kind of, you know, New York City has a law that basically allows any warehouse worker to request their data from the company to sort of measure, to get a sense of like what is the company measuring about me, what's my productivity score, all of these things. But of course, any worker on their own is not going to be able to make sense of this. And so like a kind of RCT we're trying to pilot is how do you kind of solve this coordination or public goods problem so you can get all these workers to simultaneously ask for their data at the same time, and then you can start, you know, when you have a third party that's trusted, kind of like trying to create knowledge for workers themselves about what their employer knows about them, with the kind of idea of producing some form of countervailing power to the HR analytics companies. And I'll leave it at that.
I'll sit down and let me first thank Susan for giving an absolutely splendid lecture. in so many ways, and I'll only be able to touch on a couple points. But before getting into the substance, I thought I'd spend just a minute on Kenneth, who's this lecture is in honor and a memory of. Ken is probably Columbia Economics Department most distinguished graduate. He got his PhD here. And one of the ideas in behavioral economics is it's really important to have role models. And Ken is in many ways a role model. And for those of you who are PhD students, that's the level that you should aspire to. And you should set that as your standard, that your PhD gets the kind of deserves a Nobel Prize. So that's I'll just make it clear that's what we expect of all of you. He was one of the greatest economists of the 20th century. He was my teacher in the fall of 1966, just a few years ago, and we became good friends with shared interests and values. Especially after I went to Stanford and we saw just a lot of each other. One of the reasons another reason we wanted to have a series in his honor and memory was he did work in every aspect of economics. And that's what's so great about having a lecture series, because you can have a lecture in health economics, in technological change, in labor economics. He did work in both education, and he was very interested in one of the issues that Susan talked about, discrimination. That he focused more on racial discrimination, but the general theory of discrimination was one of his important contributions. So again, in terms of one of the problems in the economics profession has been that people gotten narrower and narrower. Susan has shown that you can still say broad. I thought she was going to talk about more on market power, where she's devoted her time for the last several years. But this has been absolutely fascinating, and obviously very, very appropriate for one of the major issues that we are all facing in the coming decades. The topic, the talk, is one I think that Ken would have loved. It combines big methodological advances with the application to a set of critical importance. The first one I'll comment a little bit more that she talks about is the effect of job displacement when you lose your jobs. And it was a problem that first came to a widespread attention about a little over 30 years ago, when in the aftermath of the 1991 economic downturn, there was a New York Times series that discussed how the articles appeared in 93, 94, 95, that it began to be uncovered that losing a job has an effect not just at the moment, but for a long time afterwards. That there are long-term effects that seem to persist. And the question was, what are the causes? Very different from our standard model, particularly in macroeconomics, where people lose a job and they just move somewhere else, perfect labor market. These numbers, these figures show very strongly that when you lose a job, I mean, everybody knows that it has a big effect, but macroeconomics has seemed to ignore that, and this gives micro foundations telling us that these effects are very big and can't be ignored, and they're just. And the question then is, what should be done? It's when we have had these series for the first decade, Ken Arrow came every year and commented on the papers, and it's sad that he can't be here. But also, Bob Solow used to come very often. And Bob Solow this was one of the questions that he was very interested in. And he chaired the board of a nonprofit called MDRC. I can't remember exactly what it stands for, but what MDRC did was to do experiments. It was one of the early examples of experiments in precisely the issues that Susan was interested in. What interventions will have what effects in the labor market? And so it was before a lot of the sophisticated econometrics that we have today, but it was a clear, real example of experimental economics. The import of the kind of work that Susan has been doing is that if we can target better who really needs intervention, and if we can think of where the interventions are likely to be most effective, we can get much better interventions at lower costs. And given the magnitude of the effects that are described in terms of lifetime losses of income, that can make a very big difference. Hysteresis matters, the effects of job history matter, and if we can change those job history, shorten the time that people are in unemployment or where they have to take a much poorer job, it can make a real difference. And that's why ideas about how you can get people, how you can reduce the information frictions are so important. I want to just, since I have only a little bit more than a minute left, I want to mention 3 ideas related to artificial intelligence that are more broad. The first is the existence of deep uncertainty, the idea that there are events like the financial crisis of 2008, COVID-19, or what's happening now with Trump, are events that have no precedence. And so you wonder at how, by looking at the past, which is what any model does, can provide a prediction of the future. Now, the AI optimists begin by saying, but look at, when we're making our judgments, we're also looking at the past. We're filtering that information somehow, and if Bentley is right, these things are going to be so much smarter in filtering the information better than we can that all of us are going to be unemployed. Well, it's not going to happen in my lifetime, I don't think. That's the good news, and I don't think it's going to happen in the lifetime of most of you. But it is there is an idea here that all of us can only make forecasts on the basis of past. But the way we make those forecasts is based on more structural models, and AI will eventually maybe get to those more structural models, but I think it'll be a little while. And then the second thing I wanted to comment on AI relates a little bit to what Suresh talked about. AI does allow better price discrimination, and the question is, whether that's a good or bad thing. The fundamental theorems of welfare economics that we all sort of intuitively use in our back of our minds, the efficiency of the market, the invisible hand, are based on the assumption that everybody faces the same prices. And price discrimination is the opposite of that. Now, while it's true that with perfect price discrimination, you can get to a first best, the world is not based, will be a long time before we're at perfect price discrimination, if we are ever there. And imperfect price discrimination is, in general, worse than the outcomes of the first fundamental theorem of welfare economics. So things may get worse in the next million years before they get better. And the final thing is a two-sided thing about both good and bad. One of the concerns I have of AI is that it is getting better at pollution, polluting the information ecosystem with mis- and disinformation. Now, it's also getting better at detecting mis- and disinformation. So there's a war going on in which the information ecosystem is increasingly polluted. Those of us who don't have tools, for extracting all that garbage are facing a harder and harder time. Where this is going to wind up, I don't think is yet clear. But in the meantime, I think there are a lot of jobs for ordinary individuals to try to, on the one hand, extract truth out of the garbage that is out there, and secondly, to help design regulations that will reduce the extent to which AI can impose harms on the rest of our society. Thank you.
So I think I was supposed to react briefly, and that thank you so much for these wonderful comments. And I just wanted to highlight a quick thing or two. I think both Bentley and Joe's call were really like calls to action on research topics, which, and I'm going to come back to Suresh also, but you had one of the things that both of you, I think, really focused on is the fact that in these changes, workers are going to have to make transitions. And we are not very good at helping workers make transitions. In fact, as Joe pointed out, we didn't really identify it as a problem for a long time. So that was really the motivation for these two experiments that I ran. And I hope that they're contributing, but I think we have a long way to go. So that's a big motivation there. Just on the market power point, just connecting Joe and Suresh, I completely agree that it is just fascinating what AI is going to do to market power. I do have a little bit of work started in that direction. It's a big, hard problem. And I've been trying to think about how to connect the work that I've been doing to labor market monopsony. Because exactly as you said, I'm so glad that you pointed that out, that when you see heterogeneous impacts of job losses, that also shows that there's an opportunity for monopsony power. And it is concerning to me as well. And also just AI in general, price discrimination. When I was at the Department of Justice, we brought a case against RealPage, which had algorithms for setting rental prices. There's a lot of really interesting open questions around how this is going to change the economy. So, but with that, let's go to Q&A. And actually, I didn't ask. Am I leading Q&A? Well, anyways, someone. How are we doing Q&A? Yeah, can't.
We'll bring the mics around.
Okay, so raise your hand and mics will come.
So let me ask a question. I thought it was fascinating what you talked about at the end of the talk about the career model and how one could look at complicated aspects of histories to forecast better. A question about that, I mean, there are lots of areas of application where we would like to forecast better and where there are in principle complicated histories, but how large a data set does one need to have available to train this kind of model for this foundation model approach to in fact help us do better than the kinds of regression models with small numbers of regressors that we're used to doing?
Yeah, so actually I should have slowed down a little more on the point that one thing that's really special about job histories, it's a discrete choice model, basically. So if it was just a sequence of numbers, that's much easier to fit. It's the fact that it's 330 job ones and 330 job twos and so on. That's what creates the explosive problem. And that's why the very most recent machine learning methods have so much benefit, because the architecture of the transformer models that was designed for language are really good at getting these sequences of discrete choices. And so that's one place where the transformer models work really well. We had the 23 million resumes, but actually you could do with a fair bit less. And then, as Suresh mentioned in my most recent paper, we actually use the text model itself as the foundation model, and then we only use the public government data sets to do the fine-tuning. So you can think if you start from Llama, which is what we did, then you can work with a very small data set. So I think that's part of the promise. And this only has value if your data does have information in it that's sort of captured by text in that case. So we actually do an experiment where we train the model, we fine-tune the model with sequences of job titles in text, and then we fine-tune it with just numeric job codes. And it does much better when we put in the text, which is just showing it's not just having like a rich, fancy neural network. It's the fact that the llama is encoding information about the words carry information about two jobs being similar. Electrical engineer, software engineer are similar. So yeah, I think I've also thought about this a bit. What are the other things that have that flavor where they're economic prediction problems, but they're kind of just discrete choices with a lot of choices? Usually in economics, we just collapse those. Like you're working, you're not working. Or, you're taking care of kids, or you're working, or you're part-time. We just collapse the history. So we have to kind of go back and think. All those government surveys, those were actually like, there was text, people talked. There's like, you could actually do a lot more if you anticipated modeling in this way. But I think for like just pure macro forecasting of numeric variables, neural nets have been helpful there too, but I think the delta is not as large because we already had worked pretty hard to find functional forms that fit the numbers.
Mike, can I make one quick comment? Yeah, so one thing just to follow up a little bit, I think Joe was mentioning our students here. I just want to remind students that that Susan's work on the Swedish data actually follows up some work done by one of our graduate students, Johanna Schmeider, who's at BU, who's actually one of my students, who did some of the original work on these shocks, which is quite good. And I also mentioned another Columbia student, so I think is actually Mika Sviacci, who just got tenure at Princeton. And one of the things, and the reason I mentioned her is that what she did was to look at how a person's early career, in particular whether or not they're involved in the drug trade in Peru, would actually affect whether or not they were incarcerated later on. And so both of them, who are Columbia graduates, were sort of in the Minster tradition of looking how these early, these later market shocks, and I think Mika's work is particularly interesting. I like to see more along those lines, which is looking at 10 or 15-year horizons on looking at this history affects the future. And I think it's really important work. And I think the technology that Susan's describing has some potential to look at some really hard and important questions. So I just remind you, and this has been done at Columbia, and I'm sure all of you can do more.
Can I just add one more thing, the importance of Susan's work? It used to be thought, when I was on the Council of Economic Advisors, we were very depressed. We knew that on the one hand, the displacement mattered, but the common wisdom was the active labor market policies didn't work. And so, we were sort of in paralysis, and that's why it's so important figuring out how to target and how to design better policies and how to test which policies are working. And so that kind of, these tools become really important. And but now we know that there are policies that will work on certain groups of people. And so the fact that they might not work on average, if you don't target them right, doesn't address the question of, can we design a medicine that works on those who are most badly affected?
And so my presidential address is about to come out in the AER, and I actually go to in some link there about the product design process, and that was really kind of an inspiration for these. Instead of, again, just saying, okay, the literature says nothing works, so I guess nothing works. Instead, actually go talk to the people and, okay, I helped women going into IT in Poland, and maybe that's small, but it's a case study that then kind of tells you about mechanisms and invites further exploration. Okay, we have a question.
Hi. So the canonical production function in econ has human capital as the input, right? But there's actually in AI now agentic AIs that can do the jobs of humans. There's AIs that can do customer service. So what are your thoughts in a world where AI actually fully replaces labor?
Yeah, so there are, I think there's a panel a week on this topic, so I can try to channel all of that. But no, it's, I think first of all, we have to think about general equilibrium economics to answer that. And so, I go to a lot of computer science conferences where the computer scientists are okay, great. Technically, we can do A, B, and C, and I think we'll be able to do D, E, and F in 5 years. So therefore, we need to plan for all of us sitting on the beach and having drones drop daiquiris to us. And it's where to start with what's wrong with that vision. Okay, first of all, banks have there are tens of thousands of people around New York probably that just copy things from one database to another as their job. And you ask, why is that? It's not that we don't have the technology to automate that today, but there are other frictions that get in the way. And so it's going to take a long time for us to remove those other frictions. If you think about having every problem solved on your phone, well, what does your phone want? And actually, do Apple and Google want ChatGPT's agent to take over the phone? Probably not. So there's a lot of economic considerations that affect the pace of adoption that aren't part of the technology. A second thing is that, what's going to make everybody drop daiquiris on the beach? Who's dropping them actually, and why are they dropping them exactly? And are they dropping them on U.S. beaches or global beaches? And why does it matter that we're all happy? In a world where AI is so good, it also can support autocracy and fight wars, and so it's not clear why we're all going to be sipping our daiquiris. So I think, so that's why utopia seems unlikely. Complete dystopia also has some negativity to throw on it in the sense that we have so many frictions along the way to actually fully implement technology to replace all of us. And then, if workers get cheap, then maybe people will still hire workers. They just, because there's still something productive for them to do, they just won't pay them very much. And, there's a question of if somebody does or doesn't decide they want to send them a daiquiri. So, but bottom line is that these future predictions actually don't make a lot of sense without thinking about the economic general equilibrium, how wages change, how firms' investment changes, how governments change. They're very hard to sort out. One other thing, just coming back to the market power point that I've been pushing in a lot of my talks, is that it does matter what the market power is. If we have low markups on, if goods production gets if workers' wages fall and we don't need a lot of workers, then in principle, goods production could get cheap and then goods could be cheap too. But that requires not some competition in the people who are selling us things. And if we don't have that competition, if any place in the supply chain, somebody's got a competitive bottleneck, they can extract surplus, which means that we may have more trouble. So all pretty, we could have a whole conference on this or many conferences on this. There's theory that work, there's empirical work, but in the short term, I think thinking about transitions, this is going to be a hard transition, and we're so good at crises. We've seen this lately. We're so good at pulling together as a society and not letting it divide us. And these crises will be bigger than some of the crises that we've had in the past. And so, trying to figure out, even like having people be unhappy for 5 years might be 5 years too many in the context of global politics and so on.
So with that optimistic note, I've been told if you turn around, you can see a big sign, Joe, please close the event. So I'm a human robot. I do what I'm told. And this has been absolutely fascinating. And as Susan said, there is huge lots to discuss on all the topics that have been raised this evening. And I hope we can get Susan back again to talk more about AI, monopoly power, the transition, the politics behind this, because it's clear that AI is a powerful tool. We've seen how it can increase the knowledge we have, make us do a better job at what we do, but it does present some real challenges going forward. So let me thank you again, Susan, for a wonderful talk.